Most people brute force this solution and pass, but still fails in the similar ones. In this video, I'm going to show you how you can develop the mental model to solve and generalize 10 plus grid simulation problems. I am Arjo and you are watching Coding X.
A few moments later.
This is our today's problem. Working robot simulation. A robot on an infinite xy plane starts from 0,0 coordinate facing north. This is the initial position and direction of the robot. We'll get some commands which represent a sequence of moves or instruction. The instruction may be if we get -2, we have to turn left by 90 degrees, and if we get -1, then we have to turn right by 90 degrees. And the value of k, that is our steps that we'll take towards that direction, that value will rise from the lower limit 1 to the upper limit of 9. Okay, and in our path we might get some obstacles, and the obstacle positions will be given as an x, y, y1 coordinates. And if we find one obstacle in our path, then we have to stop just before it, and at the end we have to return the maximum squared Euclidean distance of the robot reaches at any point in its path. Okay, so this is our problem. So let's talk about the solution of this problem. This kind of grid simulation problem is highly dependent on the direction. You have to understand how the direction is related with our problem, how the direction is changing, or the problem's condition is changing our direction and is changing our coordinate system. So let's take our direction in this problem. I'll take that as a vector, because if we take as a vector, then it becomes very easy to compute the values of the coordinate system and get the direction as well. So I'll make one dir's array. Inside that I will compute 0, 1, 1, 0, 0, minus 1, minus 1, 0. This small arrays of at the 0th position, 1th position, 2th position, 3rd position is showing the north, east, south and west direction. You can understand by the sign and the values, like 0, 1 is north, 1, 0 is west, 0, minus 1 is south, because this comes the downward of the it's in the downside of the coordinate system. That's why, and -1, 0 is also a negative convention of our coordinate system. So what we'll do with this DIRs is, now at first we know that in the question it's given our robot will face at the north direction at first. So we know that our robot will be facing the north direction at first, so it will be going to be dir value is going to be 0 at first. So I'll compute that dir is equal to 0. Then I'll make one algorithm, like if we get -1, then we'll say dir is equal to dir plus 1 mod 4. What is doing here? Like if we have 0 means we are facing north, we know that if we get -1 we have to face right, that means we have to face east. To face east, we'll compute it like this. Then if I do 0 plus 1 mod 4, then it will automatically gives the output of 1, and 1 means east here, because 1 index is east, index is 1 here. And if I get -2, then obviously 0 plus 3 mod 4, that is 3, and 3 is the west direction, north, left is west. So we're getting all the inputs there, all the direction here. And in case of the obstacles, we will just see that in our coding part. So this is going to be our directional sense. Now let's code this out with our obstacles also have to compute and see the obstacles also there. Now let's code this thing. We'll make the method of robot simulation and take the commands and obstacles here. Now I'm going to dirs as I told, and I will take the dir value as 0. Now I'll make two variables, x and y, and to find out the Euclid distance, maximum Euclid distance for maximum distance. I'll make the next list. Now I will loop inside the commands, and if we find -1, then we do the t is equal to t plus 1, 1, 4. If we find -2, then t is equal to t plus 3, 4. And the is block will just know the d value, we know the direction obviously. Then in that direction we will take the values of in the dy and dx, and we'll loop inside the range of command, cause there's the most common mistake that many people do here, that they directly compute and jump the value without looking through the obstacles in the path. We'll not do that. For every steps we'll look for the obstacle, if there is obstacle or not, because we have to stop just before of them. If we found any obstacles, for that I'll make that if x plus dx and y plus dy in obstacle set. I made that obstacle set here because it's easy to look through in this set. We have done this before in our previous video. We are taking the set concept to use the lookups type. Otherwise we'll break this, or if we don't take any obstacle, then we'll do the x plus. I'll find the maximum distance, max dis, then we'll return the max distance. So this is our code. I hope you all understand this problem, and also that you understand how, if we find any gray simulation problem, I will take the direction, how we relate that with vector, then how we relate that with our problem, and find one mental model, build one mental model that goes with the current problem. So that's it for today. Thank you for watching.